So first what we want to do is take a look at just the meaning of solutions again. The meaning is we're trying to find values that when I plug them in, I get true statements. And what has to happen to be a true solution, this is for all the equations in the system. So if all three things happen, we are a solution. If any one of them fails, we are not a solution. So we're either consistent or we're inconsistent. And so in this first round, I've been nice enough to actually give you, right, I have found the values for you. So here what we have is a 2x2 system, right? There's two equations and two unknowns. And what we basically have, right, is we are told that x is 5 and y is -3. So to see if it's a system, we just plug it in. So for this first equation, we got 2 times 5 plus a -3. Does that equal 7? Well, 10 minus 3 equals 7. 7 equals 7. So far, so good. If we were just solving one equation, I'd be happy. But we're not. We have another one. So what about this guy? So plugging things in, we get 5 minus 2 times -3. Is that equal to 10? So this is 5 plus 6 equals 10. This is 11 equals 10. Right? And so that is not true. So that is not a solution. In order to be a solution, you have to satisfy everybody. So now the question begins, right? Now that we've tested that, is this consistent, right? Is there a solution to this? And we need more math, right? To determine whether it's consistent or inconsistent. Or just because you tried one point doesn't mean we're here yet or here yet, right? We actually, I just gave you one ordered pair. And there's actually an infinite number of ordered pairs out there. So just try them all, or let's figure out a way to find the one that works. We just basically were given one that didn't work. So no solution, that one's not a solution. But that does not imply that we have no solution. More work to be determined. Okay, so be very careful with your conclusions. Just because you found one that doesn't work, that doesn't mean all of them, right? So more work needed. The next one, for the first time, at least in this section, we're looking at a 3x3 system, right? 3 equations and 3 unknowns, right? And so the ordered pair is now called an ordered triplet. And just basically go in order, right? Here's x, here's y, and here's z. And I'm asking, is it a solution? So if I plug it into this first equation, we get 1 plus 2 plus 3, does that equal 6? And if we add that up, check, all right? So that one is good to go. The next equation, we've got 2 times 1 minus 2 plus 3, does that equal 3? So 2 minus 2 plus 3, those cancel out, 3 is equal to 3, so check, all right? So far, this looks like a good candidate. But in order to be a true solution, 3 times 1 plus 2 times 2 minus 3 times 3, does that equal 2? So we have 3 plus 4 minus 9, right, equals 2, right? And we get 7 minus 9 equals 2, and close but no cigar. So since this one doesn't work, that means that that's not a solution, all right? But again, that doesn't mean we're consistent or consistent yet. I just found one, right? So is there a way to actually find the actual solution? Well, the answer is yes, right? And we have to do more work in order to decide whether it's consistent or inconsistent. All I'm doing at this point is testing an ordered pair, an ordered triplet that's given to me. I can't draw any more conclusions except for what's in front of me. That's not a solution because it didn't solve this second equation, and that's not a solution because it didn't solve the third equation. So is there a solution to this out there? I don't know. We'll find out. All right, so that's basically how we test if something is a solution. Let's go do more math to try to figure out what the solutions might be.